Welcome to today's class, my dear learners. So let us start with concept number 10, that is regarding temperature. Children, what is temperature? Yes, the degree of hotness or coldness of a body is called as temperature. I repeat, the degree of hotness or coldness of a body is called temperature. Well, the SI unit of temperature is kelvins. So, the degree of hotness or coldness of a body is called as temperature. The degree of hotness or coldness of a body is called temperature, and SI units of temperature is Kelvin. So SI unit of temperature is Kelvin, indicated with the symbol K. Okay. And what instrument do we use temperature? We use thermometer to represent, to measure temperature. So thermometer is the instrument used to measure temperature. Now let us try to have a look at different types of thermometer. If you observe this, you can observe different types of thermometer shown on this picture. During the COVID time, you would have observed this type of thermometer. This is generally called as your radiation thermometer. This radiation thermometer is being kept on our forehead. Without touching the body, the temperature of the body is being calculated. And this is the clinical thermometer. Often, if you visit a clinic or a doctor, he will be measuring the temperature of any human body with the clinical thermometer. This is another type of thermometer. Recent days they are using this type of thermometers. This is called as a digital thermometer. Let us try to understand properly regarding this clinical thermometer or any type of thermometers. Okay. So, if it is a bigger size, it is used for laboratory or laboratory thermometers. So, general thermometers will be having this type of appearance. This thermometer, if you observe this, see the green color inside which if you observe, it will be having a thin, narrow hole will be there. Thin or narrow hole will be there. And to this part, here you can observe that some glass bulb is being attached, which is sealed on the one side. In this glass bulb, this is very sensitive glass bulb in which mercury is being kept. As and when the temperature is increased, this mercury inside the sensitive glass bulb starts expanding. And as I said that here it is a narrow hole is there. That narrow hole itself is called as a capillary tube. What is that called as, children? It is called as capillary tube. Here let me write it. Capillary tube. Okay. The air inside the capillary tube is being sucked and it is being evacuated. So, no air is kept over there, only vacuum is being kept. So, because whenever the temperature increases, this mercury starts expanding and this will be occupying the space inside this narrow hole. Are you getting me, children? Okay, so this itself is called as capillary tube, or also called as that narrow hole is called as your bore. Narrow hole is called as your bore, and the protection, the shielding is made up of very thin glass tube. This green color is a glass tube that is called as a capillary tube. Inside that evacuated chamber is called as bore, inside which the mercury starts expanding. Shielding it, protecting it, one more thick glass will be there. This is called, this yellow color portion, until here if you can observe this complete portion, this thick portion itself, this complete portion, the thick portion itself is called as stem. What is that called as? Stem of the thermometer. This yellow color is called as stem of the thermometer. That green colored glass tube, narrow, very thin glass tube is there. That is called as your capillary tube, inside which the evacuated chamber is called as bore, and here it is kept inside a sensitive glass bulb. Some mercury is being kept. With the increase in temperature, this mercury starts expanding and that will be occupying the space inside that capillary tube. And every reading is marked on this stem. Graduations are made on the thick stem, something like this. It has been calibrated. Calibrated means the readings that are made, the markings that are made. Let us suppose that it is 0 degrees Celsius, something regarding 10 degrees Celsius. Celsius scale I am using. Okay, generally thermometers are marked in Celsius scale. Okay, so this is again 20 degrees Celsius, 30 degrees Celsius, 40 degrees Celsius, and so on. It is been marked on that thick glass tube called as stem. I hope you understood the concept of thermometer. So here if you observe that like this and like this, if you observe that general thermometer, okay, consists of the lower value, whatever the lower value, lower fixed point is the lower reading is there, this is called as a lower fixed point or lower standard point, which marks 0 degrees Celsius. What is 0 degrees Celsius? Do you know, children? At 0 degrees Celsius, ice starts melting. Hence, this lower fixed point also simply written as LFB. Lower fixed point is nothing but 0 degrees Celsius, which represents the melting point of ice. Whereas the highest point, highest marking here will be 100 degrees Celsius, and this 100 degrees Celsius is the highest or the last stage, and this is called as upper fixed point or upper standard point, marked at 100 degrees Celsius. Do you know water starts boiling at 100 degrees Celsius? Hence, the boiling point of water is marked as upper fixed point, whereas the melting point of ice is marked as lower fixed point. And the range of general thermometer is from 0 to 100 degrees Celsius. So, how many Celsius are there? 100 minus 0, totally 100 calibrations are made on this thermometer. And moving ahead, we also observe many types of thermometers, like other scales, thermometer readings, like apart from Celsius, we will be using Kelvin scale also. How this degree Celsius or Kel is connected with Kelvin scale. So remember that, children, every 0 degrees Celsius, 0 degrees Celsius is equal to 273 Kelvin. I repeat, 0 degrees Celsius marking on Celsius scale is equivalent to 273 Kelvin on Kelvin scale. That means 100 degrees Celsius will be equal to 373 Kelvin. So, 0 degrees is represented as 273 Kelvin and 100 degrees Celsius is 373 Kelvin. If lower fixed point in Celsius scale is taken as 0 degrees Celsius, then on Kelvin scale it is considered as 273 Kelvin. The upper fixed point on Celsius scale is considered as 100 degrees Celsius. The same on Kelvin scale is considered to be 373 Kelvin. And total number of readings is 100 minus 0 is again 100. Here also 373 minus 273 is again 100. Suppose if you would like to measure 5 degrees Celsius, then how much it would be on the Kelvin scale? So 0 means 273. 0 plus 100 is 100. So 273 plus 100 is 370. So 5 degrees Celsius is equals to 273. This is nothing, the 5 degree can be written as, let me explain, like a 5 degree Celsius is nothing but 0 degree Celsius plus 5 degree Celsius on Celsius scale, which is also equals to 273 Kelvin plus 5 Kelvin on Kelvin scale. So this is how much is it? 0 plus 5 is 5. So on Kelvin scale it must be equals to 278 Kelvin. That means every 1 degree rise in Celsius scale will be equal to the 1 Kelvin rise on Kelvin scale. Suppose on degree Celsius scale, if you increase x degree Celsius is there. So 5 degrees means 273 plus 5. X degree Celsius means on Celsius scale means on Kelvin scale it must be equals to 273 plus that x Kelvin. So whatever the increase in reading will be there on the Celsius scale, same amount of increase will be there on the Kelvin scale as well. So children, earlier I have discussed you types of thermometers like radiation thermometer, clinical thermometer, laboratory thermometer and so on and so forth. But there are some conditions where the highest temperature, only up to 100 degrees Celsius we are able to measure that whatever thermometers I have shown you till far. But there are some temperatures which are more than 100 degrees Celsius. For example, if you would like to measure the flame, okay, candle flame or any flame if you would like to measure, it will be too hot. It might be more than 100 degrees Celsius. In that case, if you take this general thermometer to that fire, then no doubt this will the mercury will start expanding more and more and more, and there won't be any provision to expand more, and there is every possibility so that the glass may break, the thermometer may break. So for this type of thermometer, we will be using different types of thermometers. Okay, to measure this type of temperatures, you will be measuring using different types of thermometers. And in TV broadcasting and all, you would have observed that their maximum and minimum thermometers are being used. That means during daytime, it has higher temperature reading is being noted, and night time lowest temperature is being noted. So based on this, this is called as a maximum and minimum thermometer. This is like the shape of this thermometer will be in the form of U. So here U is written now. So U shape. What shape is there? It will be having a U shaped tube where the lower minus 30, minus 20, minus 10, upper 50, 40 and so on. So like that it is being marked. So even the negative temperatures are also being marked and the positive temperatures also been marked. So there are many varieties of thermometers are used, and this type of thermometer which we will be using for TV broadcasting and all, for weather forecasting and all, we will be using this maximum and minimum thermometers. Okay, that is during the daytime and night time, lot of variation in the temperature is there, and in order to measure that, we will be using the maximum and minimum thermometer. I repeat, the lower fixed point, melting point of ice is 0 degrees Celsius. Upper fixed point, boiling point of water is considered as a 100 degrees Celsius. I hope you are getting me, children. Apart from that, you need to understand clearly regarding the clinical thermometer. So let us have a look at the clinical thermometer, and then we will move to the objective part. So next topic would be a clinical thermometer. Okay, clinical thermometer. So clinical thermometer is that type of thermometer that we will be using in hospitals and all. So children, in clinical thermometer, if you observe, it is also similar to the normal temperature that will be thermometer which we'll be using. On the clinical thermometer, the lowest marking will be 35 degrees Celsius. The lowest marking will be 35 degrees Celsius, whereas the highest marking would be 43 degrees Celsius. So what is its range, children? It starts from 35 degrees Celsius to 43 degrees Celsius. This is the range of the clinical thermometer. And you need to know one more thing is that the normal temperature of a human body, normal, a good health, a healthy human body, okay? Healthy human body I'll be writing. For a healthy human body, the temperature will be 37 degrees Celsius. A healthy human body always possesses 37 degrees Celsius. If he could not able to maintain this 37 degrees Celsius, if the body's temperature is either greater than 37 or lesser than 37, we need to understand that that human body is not healthy enough. And one more thing is that if the temperature of a human body crosses 43 degrees Celsius or falls below 35 degrees Celsius, there is every possibility to occur a death of the human body. So be careful that the temperature will be in the range of 35 to 43 only. In other cases, if above 43 or below 35 degrees Celsius, the death may cause to the person. So always keep healthy. And one more thing, children, whenever you will be using the thermometer, make sure that the thermometer is washed properly with warm water and is shaken completely, and then it is kept under the tongue. And again after the use, again you need to wash it and again keep it in a safe place. And one point you need to remember that don't clean the thermometer with hot water. So if you use hot water, it might be 100 degrees Celsius or more than, okay, up to 100 degrees Celsius. But the clinical thermometer is only 43 degrees Celsius. So because of that hot water, the mercury may expand more than this 43 degrees Celsius and there is every possibility to explode. Okay. So be safe and always use warm water to clean this clinical thermometer and maintain good health. Okay, children. So now, based on the above concept, let us try to solve few numericals.